Okay, so tonight we will be focusing on WSQ number 3, which is proving triangles are similar by SSS, side, 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 and SAS, side, angle, side. Okay, so as we discussed in class today, we did focus on AA similarity. So to prove similarity between two triangles, one option is that if two angles of one triangle are congruent to two angles of another triangle, we know automatically those two triangles are similar. So again, if angle A and angle D are congruent, angle B and angle E also have the same measure, we know triangle ACB is similar to triangle DFE. Okay, that's the first method. For the second method, we're going to look at SSS. So this is very similar to what we did last semester with side, 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 except now we're not looking for congruent sides, we're looking for the measures of the corresponding side lengths of two triangles to be proportional. And so that might not make a lot of sense to you. You might be saying, well, what does that even mean if they're proportional? All that means is they have the same scale factor. So if we look at this example, we notice we have two triangles, A, B, C, D, E, F, that have three side lengths given. You know nothing about their angle measures. So we're forced to use the side, side, side similarity postulate. So the easiest way to do this is to go ahead and set up what's called your statement of proportionality. And I'm going to look at triangle ABC. And I'm going to list the side lengths in order from smallest to greatest. So I'm going to look at 6, 8, and 10. And again, I got those right from this triangle here. Now if these are similar, the shortest side is going to match with the shortest side on DFE. Okay, the longest side is going to match with the longest side on DEF. Okay, so I want to just right underneath go ahead and do the same thing for DFE. So I'm going to start with the smallest side, next smallest side, and the largest side. Now my sides match up. My shortest sides are here, my medium length sides are here, largest sides are here. The last step is to reduce. If they all have the same scale factor, they're similar. If they don't, they're not similar. So let's go and reduce 6 over 9. Looks like that would be 2 to 3. Okay, 8 over 12 we reduce. It's also 2 to 3. Reduce 10 over 15. It's also 2 to 3. So this checks out. So we'll go ahead and write a similarity statement. So ABC similar to DEF by SSS. Done. Okay, so let's go into the next one. Side angle side is just a combination of the two. So we're going to look for some proportional sides. We're also going to look for some congruent angles as well. So go ahead and read through it. So the measures of two side lengths of one triangle are proportional to the measures of two corresponding side lengths of another triangle, and the included angles are congruent. Okay, so probably the best thing is to go ahead and look for any sides that you know will match up. We can use the same thing. We know we're missing a side here on both triangles. So I'm going to look at my two sides I'm given. I know I got a 3. My next biggest side is a 6 for that triangle. Okay? I'm going to go ahead and skip to this other triangle, the larger one. I'm going to start with my smallest side, which is a 4, largest side, which is an 8. Okay? And again, that's just a good habit to get into, to list in order from smallest to largest, and do the same thing right underneath for the other triangle, smallest to largest. This is already reduced. Let's go ahead and reduce 8 over 6, or 6 over 8, I'm sorry, which is also 3/4. Okay, so we have the two sides, okay, because they have the same scale factor. All we need now is an angle between those two sides to be congruent. So you can see I had these two sides, and what do you know? Angle N and angle R are congruent. So these two triangles are similar using side angle side. So I can write triangle NMP similar to triangle RQS by SAS, side angle side. Okay, and again, all we want is we're looking for two scale factors to be the same, and right inside those two sides where they meet, those angles need to be exactly the same. And in this one, they're both 70. Okay, so we're going to try an example with some of these. So I want you to determine whether these triangles are similar. If so, write a similarity statement for me and tell me why. So are they similar by AA, or similar by SSS, or by SAS? Okay, so go ahead and pause the video now. Okay, so let's see how we did. So first one, again, you'll notice we have two different triangles. We're missing a side length here and here, so it's probably not going to be the easiest to use side, side, side. Okay, there's a way to do it, but you won't even need to do that for now. Let's look at what we do have, though. So let's find our scale factor and see if our scale factors even match. So I'm going to look at triangle JKL and look for my smallest side, okay, which is 20. Okay, and then I'm going to put my other larger side on the top still, but right off to the right. Let's go back to triangle WXY. Find the smallest side, 18. Okay, find the next one is 24. Let's reduce and see what happens. So 20 over 18, we have a common factor of 2 we can reduce by. That's 10 over 9. 36 over 24. Looks like our greatest common factor is 12. Okay, eventually if you reduce by 2, you could keep going, but we should have 3 over 2. Those are the lowest possible terms, and notice they don't match. So with these, they have different scale factors. They're not similar. Okay, although they do have that angle in here. Okay, if they did have the same scale factor, they would be similar by side, angle, side. Okay, but they don't have that, so again, it is going to be not similar. Okay, if you didn't pause the video to try the second one, go ahead and do that now. Otherwise, I'm going to go ahead and go over it right now. Okay, the last problem, again, look at what you're given. We have side, and another side. Okay, so we pretty much have to use side, side, side. That's really the only thing we can use on this problem. And let me get my eraser so it's off here. Oops. Okay. So let's go ahead and set up our statement of proportionality and check. So again, I'm going to start on triangle GHI, this one here. Let's look at the smallest number, 24. Go in order, next one's 32. Go in order, the biggest side length is 40. Let's go back to QRS. Smallest one is 25, next one is 20, next one 25. Okay, so no angles, so we're going to rule out AA, we're going to rule out side angle side. The only possible option for this one is going to be side, side, side. So let's reduce 24 and 15, common factor of 3, reduces down to 8 over 5. Okay, 32 and 20, common factor of 4, reduces down to 8 over 5. 40 and 25, common factor of 5, 8 over 5. So you'll notice that these are similar by side, side, side. So I'm going to write that up here. I don't have a ton of room. So triangle IGH, similar to triangle SQR by SSS. And there we go. Okay, so go ahead and make your posting on Schoology. That's it for tonight. We'll practice this a little bit more tomorrow, and have a good night.